Building APIs in a RESTful style has been very popular for quite some time. Making disparate applications work together has been a challenge for a very long time. So REST is something that's a technology that has now become very popular. However, there are interesting alternatives that are emerging in the marketplace. There are also reasons why REST does not fit in a right fashion for certain scenarios. The goal of my presentation today is to explore the history of our API landscape over a period of time, see why REST is popular, look at some of the challenges when it comes to building APIs using REST, and also explore the landscape where different alternate technologies are slowly emerging. So just like how humans have evolved or progressed or digressed over a period of time, our APIs, the way the technology that we use for building APIs, they've also evolved over a period of time. So way back, people realized that exchanging physical documents did not make a lot of sense. With computing being popular, people started exchanging data in an electronic format. That's how EDI became common. And then people realized that it's not just exchange of information that's important. How do we make remote systems appear as if they are part of the local system so that they can seamlessly work? That's the goal Corba, DCOM, Java, RMI, all of them attempted. Many of these technologies, for quite some time, they've gone from being bleeding edge technologies to becoming widely adopted, and then they're all gone into a state where people switched over to new technologies. So many of these technologies failed eventually due to a variety of reasons. Some of them failed because they were not properly implemented. Some of them, they were not very easy for users to consume it. And some of them, they failed because they built artificial walls around it, saying that you can use these technologies only if you use this specific operating system or only if you use this specific programming language. So soon, people realized that XML was getting very popular and HTTP and the web tech was getting very popular. How could we make systems communicate over the web using the same HTTP and the same XML? And that's how XML RPC came. XML RPC allowed us to invoke procedures across many different systems. And XML RPC was soon followed by SOAP. SOAP was proposed by Microsoft. SOAP allowed a lot more message exchange patterns than what XML RPC was originally allowing. And SOAP, it came with suite of additional offerings like that covered various aspects like security. It came up with WSDL. It came up with the approach of having a very nice way of defining the schemas, and SOAP seemed to be more widely adopted, and for a while it seemed to be more voice with aligned that SOAP is the future. Just when we thought SOAP, we have settled on SOAP, people realized that REST is a better or a nicer, easier way of doing things. REST is an architectural style proposed by Roy Fielding for hypermedia system. REST proposes a set of constraints. These constraints, when applied properly, it made it easy for distributed systems to communicate. Some of the constraints are client-server separation. This allowed servers to more focus on how the information need to be stored, and the client to focus more on how it can handle the UI concerns. A stateless server, this allowed servers to be scaled in a better fashion. What statelessness means is every client request should contain enough information for the server to go ahead and execute this request. There should not be a need for the server to remember any mapping between the past requests and the future request. Caching is another interesting feature. I mean, SOAP did not support caching in a very big way. The idea about caching is whenever server renders a response, the server also tells that how long this response is valid so that clients can take that response and work using that response instead of making additional calls to the over the remote network. This is the biggest benefit, like uniform interface. The idea of organizing things by resources, many different representations, and using HTTP verbs, it caught everyone's attention because it was very much into our mental map of how we do create, update, and delete things. The same concepts fitted very nicely with the HTTP protocol, and it became more popular for building APIs. Again, layered system, you can have stack of layers. Like yesterday's class, there was interceptors. You can have many different interceptors. Each of these interceptors, by following layered system approach, they just talk to systems below them or above them. They don't have to have any knowledge beyond the systems down their stack. So all of these, code on demand is an optional constraint that allows clients to download certain code and execute. Many of these constraints made developing API very simple. And other than this, there was a new format for data exchange that was getting popular, that was JSON. JSON was a lot more simple than XML, and many people who did not like writing many schemas, they could get a head start by using REST and JSON, because JSON schema came as an afterthought as against having to write the whole SOAP APIs with schemas. It made more lightweight, and the ability of browsers to directly interpret the JSON, it all led to REST's popularity. There is an interesting graph of how popular different APIs are. This is an old graph that I could get from a magazine called Infograph. As early as 2011, when asked people around what technology you're using for building APIs, REST seemed to have garnered a lot of the mindshare. SOAP was still playing a very big role because many of the COTS products, many of the legacy applications were built using SOAP. So now, like 4 or 5 years down the line, I think we could definitely say that REST is more popular. So just among the organizations, how many of you plan to build new APIs using REST? Could you all raise your hands? Nice. So how many of you want to build things using SOAP? Yeah, so that's a more updated survey result. I mean, it's very clear that REST has become extremely popular. So here is an interesting quote by George Fairbanks. He's also one of the co-chair of the SATURN conference. I happened to read his book called Just Enough Architecture. This one was very interesting. So he says a concept of presumptive architecture. So presumptive architecture is the architecture that's very much popular in a particular domain. So what happens is eventually anytime you want to start building something in that specific domain, you start picking this presumptive architecture without applying a lot of thought. That's what is slowly happening to REST. Anytime we want to build any sort of API, we, rather than justifying why we should use REST, we just need to justify why we should not use REST. And many people who are not intellectually curious, they wouldn't even make an attempt to see what are the new things that are available. But we being architects, I think we all are having that nature towards being curious and trying to explore what are the new technologies that are available. So that's why this thought come across in my mind, that what is it that we have as alternatives other than REST, apart from the legacy technologies that have already been there. So that's why I wanted to give this presentation. So this is another quote. So I'm having too many quotes, but not any more quotes. So this is a quote by someone called George Santana. He's a philosopher. Those who cannot remember the past are condemned to repeat it. So if what past teaches us is any technology has a wide adoption, and then there's a lot more people wanting to use it, and eventually it fades it gets replaced by new technologies. The same thing could happen to REST. It has been widely adopted, but that doesn't mean that REST would forever remain the prominent technology. So it's important for us to see what are all the new alternatives that are emerging. It might not happen the next day, but to keep an eye around new technologies that are happening would help us align our goals with many of these new technologies. So what are some of the challenges with REST? So OSFA stands for one size fits all. The REST APIs are very much built keeping the ease of the server teams. The teams that provide the REST API, they very much don't care about many different consumers, because they go with the REST model. They go ahead and identify many different resources. In case there are clients with varying needs, for many of the use cases, it's the responsibility of the client to adjust according to the resources defined in a REST API as against to the server team making some changes. It's good in a way because the server teams, they can focus without having to support many different use cases. Multiple round trips, right? So many of the REST APIs, they are built with this resource model. So let's say you have 3 or 4 resources, and your page that you want to show information to the user, it might make multiple calls to many of these resources. So this results in multiple round trips, and it decreases the experience of these users. I mean, even without many different consumers, I had building some of the APIs for our internal teams, where we had customer-facing app, where we had internal app, and where we had some mobile apps. the way in which the users wanted to see things were very different, and the REST model posed some challenges because everybody wanted to get a different view, and the resource model did not support it in a very rich fashion. Versioning and style was a standard. I mean, REST is an architectural style. What exactly is a RESTful API is still very much under debate. Despite being widely adopted, everybody has a very different opinion around what is REST, what is RESTful. Even Richardson, he went and proposed a maturity model for REST, saying that level 0 is where you start using HTTP. Level 1 is you start using the get the HTTP verbs. Level 2 is you start using the resources. And level 3 is when you start using the hypermedia or hyperlinks. And as per Roy Fielding, the original author of REST, I mean, any API that's not using hypermedia is not RESTful, but unfortunately the definition has gone beyond the hands of the actual guy who caved the REST. People use the term REST all over, calling any kind of API that works over the HTTP, to a large extent working with resources. Again, this lack of standard, it leads to very primitive tool set for many of the consumers. It makes the life easy for server-side developers, but when it comes to consuming, I don't have a way to generate automated client steps. So many times when we develop RESTful APIs, we have many different clients coming up and asking client steps, but forcing them to write these client steps, it's not a right way. Any API in a true spirit should make this interoperable in a very easy fashion so that someone can easily generate client steps, but that's not really possible with REST. New tools are emerging. I'd visit them after some time in this presentation. Again, REST, this is very true for JSON. REST endpoints are weakly typed and they lack machine-readable data. This is changing a bit with some new market trends that are happening, but again, it's not yet widely adopted. To a large extent, REST API definition lives in a document, and you expect humans very much to read, understand the document, generate their client steps, or you have teams that publish the client steps, but it's not in a very automated fashion. There are also new interesting additional use cases that are emerging. These use cases demand the use of technologies that are not really RESTful. I'll go through some of those use cases in the subsequent slides. So I'm categorizing the many different new use cases that are emerging into different buckets. So this is the first bucket. See, the orchestration or experience API. So we have many different clients who want to start consuming the REST API. They're spread over many different kind of devices. In a web model, you had a browser. The browser was making requests to the server, and the server rendered all the response. It was very much working. The server probably would make REST calls, or the browser code could make REST calls. But however, this is changing. Many different mobile devices, each with its own constraint, they're all coming up. So it becomes important to start supporting them in a better fashion. LSUD stands for large set of unknown developers, and SSKD stands for small set of known developers. Initially, when we build APIs, it was very much geared towards supporting many different developers, but however, it's changing. There are many teams which are building mobile apps, and it's important for these teams to provide optimal experience to the users. So that's the reason why people are tending towards how they can make APIs that enrich the experience. Device-specific wrappers, this is the approach some of the teams do. So they have a REST API, they write device-specific wrappers, for example, one for iPhone or one for Android. These wrappers are written by the server team, and for a while they seem to work fine, and eventually they realize that it's too much of a maintenance. Query-based API, Facebook tried this something called FQL, which is a Facebook query language. You have like a database, like a query mechanism, so that you can query different things. That's another approach that the teams are taking. Experience-based API, this is a new trend that's happening. What is happening is the client team itself is responsible for maintaining an experience-based API. The responsibility is shifted from the servers to the client. Again, it's an additional overhead, but what it provides you is the client-side code can very optimally support the platform that it's built for. For example, there could be a platform which is not very much suited for JSON data, but this something like an experience-based API that's written by the client side could very well take the data, format it, and return to many different mobile platforms. So here is the example of the initial trend. We had many different devices. All of these devices were communicating to the REST API. This is something that happened in Netflix, so I was able to take some of these diagrams and definitions from some of their websites. So from this model, they initially tried to change to a different model, which is start building experience-based API. If you see this model, there are different APIs which are written for a very specific set of devices. Again, it's an overhead, it's more cost, it's not something that's for all kind of models, but in case if you feel that that cost is justified and providing that optimal experience for those devices is a make or break decision for the organizations, there are certain organizations which take this approach. Did it? No. So there are few new trends that are emerging. The first one is GraphQL. So GraphQL is a query language that's proposed by Facebook. Facebook was also built as a web-based company. They were very much into supporting client applications through the browsers. When this mobile revolution started happening and more people started accessing their website using the mobile, their initial reaction was to just support the application using the mobile browsers using the HTML5, but that did not provide a very optimal experience. So soon they realized that they got to revamp the infrastructure, they got to improve the experience across these devices, and they wanted to do this in a very consistent, repeatable fashion. So that's when this specification called GraphQL, they invented this, and then now they've kind of published this, and it's an application level protocol, and it's soon going to have a lot more information. The difference between the GraphQL is it gives the responsibility to the clients to specify what information they want. This is very much different from the server RESTful API where you have standard resources and you get the responses for all kind of data. The clients now have the choice of telling what kind of information they want, and the server is capable of taking that, understanding the request, and then responding back. And then it's a very hierarchical model. The way in which the client, at least for Facebook, they think about their domain model is that of a graph. Let's say you have different friends. You can ask a single query that's going to get information about you as well as your friends. This hierarchical way of querying is inherently supported. The query language is strongly typed. Again, I'll show an example query in the next slide, but for every specific attribute, there is a type that's corresponding to that attribute on the server side. So in case if someone is typing a query that's incorrect, the benefit they have is they can use the tools that are provided at the client side and identify what is wrong about the query. Again, the language itself is introspective. So what does that mean is for a specific, let's take something like a resource, what is it that's supported? What are all the different queries that I can do with it? This information is very much tied into the language itself. Using the same constructs, you could query the language and know what kind of operations are supported or not supported. They're using a very lightweight version-free way of doing it, and they have been able to support many different API calls for years across many different devices. And then their versioning works like keeping things in a very backward compatible fashion, either giving a default value to values that are to be retired or introducing new values without disturbing the existing values. That's how they're working. This way, they're able to support billions of API calls on a daily basis. They also support something called as mutations and subscriptions. Mutations is like write operations, and subscriptions is like asynchronous read. Let's say something changes on the server side, you can subscribe to certain subscriptions, and they're capable of pushing the information rather than client side having to make additional API calls. So this is an example of a GraphQL query. If you see the query very much corresponds to the JSON response that is returned, and the choice of forming the query lies on the hands of the clients. The clients can choose what they can specify in the query and what they cannot specify. So similar to GraphQL, we also have Falcor. Falcor is a JSON library that's introduced by Netflix. The model is again very similar. How could we allow clients to specify what they want rather than server giving them predefined set of things that they could query? So they tried REST. Rest did not work out for them. They tried moving into a REST-ish XML RPC style combination. That also did not work out. They took the best features of REST, best features of XML RPC, and they have come up with this client library called Falcor model. So the way it works is your data is the API. As long as you know your data, you know how to get it. You don't have to make calls. They provide a client library which hiding many of the details from you makes different calls to the server. You use a regular get set operations on a JSON data, and they get translated into API queries over the network. What they have really made different is every call and the response, they've made it by nature asynchronous, and they have introduced a client level caching. The caching, in case you're asking for an information that was asked again, there could be certain metadata information specified by the server, and that information could be served by the client cache instead of having to reach out to the server. They're also introducing batching, whereby, let's say you're asking 10 different things. Rather than making 10 queries, the batching approach collects all of the different things that you're asking and makes a single call to the server, reducing the round trip. They also do something called as request deduping. What it essentially does is, in case you're asking something that's a duplicate, it eliminates those duplicates so that the server does not have to take multiple requests for the same kind of information. So here is a model. I mean, you have your entire data exposed as a JSON. The clients operate by using the regular get, set, or the call operations that are available in the JSON. There is a router on the server side. That router is the one that's capable of understanding this JSON. For many different requests that are coming, that router could very well leverage the existing infrastructure, make calls across many different systems, and return the information in an asynchronous fashion. So this way, someone can reuse some of the existing infrastructure. Okay. So just as these orchestration experience APIs are getting popular, so is the concept of binary protocols. Anytime we send information over the wire, the information is sent in bytes. In a text protocols, you can take those bytes, you can directly interpret them. In a binary protocol, the information is very much organized in a way it's suitable for machine reading. This results in a speed of transmission and interpretation. Also, many of these binary protocols that are newly in the market, they provide native binding for many different languages. So this way you can use these libraries and generate your stubs in many different languages. They provide better versioning support. They provide interface description language. So they're mainly used for machine-to-machine consumption. And many organizations internally, in case they want to achieve better performance, they've started using these binary protocols. So some of the common binary protocols are a protocol buffer. That's again specified by Google. Apache Thrift, that's one by Facebook. Avro, it's another data serialization format. They all have majority of the characteristics that I said earlier. What is different about protocol buffer is like initially they just introduced the data serialization format. They did not provide an RPC library, but now Google has come up with something called as gRPC, which is going to use many of the good features of HTTP2 and support building RPC kind of applications. Facebook provides an entire application stack that you can build using the Facebook's Thrift. The beauty about Thrift is like you can vary things about how the transportation happens, how the server is built. You can vary many different things, and Facebook provides many good libraries for doing this. There is a site called Evernote. This site, what it allows is it allows you to move large number of data between many different mobile applications. This site has not really picked REST. They've in fact standardized Thrift and built many of the public APIs for many different clients using Thrift. Avro is a bit interesting because unlike the other models, Avro allows you to define a schema, and it stores the schema along with the data. So this all results in better negotiation. So just like binary protocols, another important feature is the asynchronous API. So supporting asynchronous API has become a big need. For SOA, we have event-driven architecture where you don't want many different services to talk to each other. Many of these asynchronous APIs and these technologies are very much different from the REST technologies. They don't fit into the REST model. Trying to force REST model for these kind of technologies is not a logical fit. Many of them, they come up with loose coupling as their main characteristic. They're all designed to be well distributed so that you can have a mechanism in which you can manage many of these asynchronous information in a highly available fashion for the entire organization. Also, with growing Internet of Things, we're going to have proliferation of devices. it can't be possible to make these devices talk to each other in a very asynchronous fashion. So again, these asynchronous APIs like MQTT is a new kind of technology that's coming up for resource-constrained devices. The concept of message broker or message-oriented middleware is not new. We have seen many different message brokers that were supported over a period of time. All of them, they fit into this asynchronous API model. So there are two interesting technologies that I'm going to brief in a minute. AMQP, it's a standard that's initially proposed by Chase. So many of these message-oriented middleware, they did not have a standardized way of exchanging information. What it meant is everybody was tying to specific vendor. With AMQP, that's the dependency that Chase is attempting to take away. AMQP plans to become the standard for publishing and subscribing asynchronous information. There are many different protocols, many different applications like RabbitMQ, Windows Azure Service Bus, which are all built on AMQP. What they promote is interoperability so that people are not tied to vendors, and they encourage best practices which could be shared across vendors. So just like AMQP, another interesting technology that's getting popular for many of these asynchronous messaging is Kafka. Kafka, it's a redistributed commit log for publish subscribe. There are inherent features in the Kafka that allows to scale beyond what many of these traditional AMQP applications could scale. Unfortunately, I'm running out of time, so I can't just go and elaborate all about Kafka. But the cool thing about it is the same kind of hardware you run Kafka was as traditional AMQP applications are like RabbitMQ. The ability for Kafka to support many different clients and many different messages is a lot more than what these could take. It was initially made open source by LinkedIn. So there are interesting new REST standards that are emerging in the market. Like many organizations, they strive to build internal standards because even 2 or 3 departments within the same organizations, they start building REST APIs. There is room for variance in many things, right from how resources are structured, how queries are made, how pagination is done. So there is not a standard. Organizations, they start building their own internal standards. But an interesting standard that's emerging is the OData standard. It was originally proposed by Microsoft, kind of failed 2 times, but now they're trying again, and the 3rd version of the standard is coming up. There are many different organizations that are partnering to build a RESTful standard. And similarly, Swagger, RAML, they are new tools that are emerging to specify how the REST APIs need to operate. So they're all still emerging. They've made OpenAPI public, and hopefully the rest is also reinventing itself so that more than a style, it also becomes a standard. So this was the main reason around why I picked this topic for presentation. I mean, it's important for us as architects to build awareness around new technologies, and we should be pioneers in adopting new technologies. I mean, not on a wide scale, just like when they're introduced, but keep exploring them, find use cases, add more value to elaborate some of these emergent technologies. And also be aware about the choices when it comes to standards that are available in the RESTful API. Thank you so much.